Hey, it's Mr. Dean here, and it's linear programming. It's one of the best topics. I really like it. It's complicated, but yet the pieces come together, well, and fit together like a jigsaw puzzle, and it makes sense, hopefully, when you get the big picture and you get to see what's going on. And it's also applicable to the real world, very sort of concrete examples. It's used in the world of business to maximize profit and minimize cost. And the first step is to set up a mathematical function that represents cost, profit, or some other quantity to be maximized and minimized. And these are subject to the constraints of the problem. So real life problems, sometimes you have boundaries you have to be within, and that takes care of all this at the same time. I made up a problem here that could happen in real life here. A luthier can make both guitars and banjos. She gets $800 for each guitar, $300 for each banjo. She cannot make more than 50 of each kind, maybe due to some constraint in the amount of wood she has, the amount of time, the amount of labor she has, or whatever. And she cannot make more than 80 instruments total. This may be per month or whatever. You can add another constraint in there with time. But she must make at least one-third as many guitars as banjos. And the question is, she wants to make the most money. How many of each kind of instrument should she make? Should she make all guitars, no banjos? Should she make some sort of combination in there? Might be more likely, you don't know. So let's get to it. First thing is probably to reread the problem because there's usually a lot to unpack in these problems. But we'll assign a variable and we'll use x's and y's because we are going to graph these. So we won't use g for guitars and b for banjos, but we'll say that x is the number of guitars, y is the number of banjos. All right, so we got guitars as x and banjos as y. And then we'll write an equation for what we want to maximize or potentially minimize in a problem. So we want profit. We want to make money, or she does. So we will say that it's $800 for every guitar. We'll assume that this is all profit, and $300 for every banjo. And we'll just set that to, we'll just call it it's called the maximizing or sometimes minimizing if your costs, you want those to be less. But we don't need really a variable there. We'll just put a dollar sign, or sometimes I'll see just the word max, all right, to remind yourself that it's maxed out. So 800x plus 300y, we'll keep that in mind. I retyped the problem up above because we're going to need it again. So next we're going to write each constraint that's part of the problem as an inequality, and then we'll graph it. So this says we can make no more than 50 guitars. This says we can make no more than 50 banjos, and of course we can't make less than 0, so I added that in there too. It's kind of an obvious part of it. This is the part where guitars and banjos must be less than or equal to. She cannot make more than 80. So she can make up to 80, but no more than 80. And then she must make at least one-third as many guitars as banjos. And just check that, make sure, some people may have it looking, whoops, I have it the wrong way, it's going to be more. Have it looking like this, or they may have the inequality the other way. Just those problems give that a real good thought about why it's y divided by 3, why banjo is cut into thirds rather than guitars. But now we got the constraints, and we graph them. And you can graph them on your TI. You can graph them um, into Desmos, which I hope I have here. Yep. So I went into Desmos. The one thing Desmos couldn't do was, if I can highlight it here, I don't know. Desmos had a hard time understanding. I had on the left-hand side, I had 0 is less than all that. It gave me an error, so I didn't have to bother with the 0, and if I got rid of it, it started to understand what was going on. So the other part with Desmos is it's shading in, and there's overlapping shading, and it's kind of hard to see what's going on. So let me go back, and we'll go here. Let's clear up here. So what's happening here is this is the number of banjos. We got to be, whoops, sorry. This is the number of banjos, the Y, and lower than this. So if I shaded this all in, they would all be shaded in there. But I won't make it too confusing. This is the number of guitars shaded in, and it's going to be sort of shaded in all that. But again, I'll try to keep that kind of clean and not shaded in. And then this number is got to make at least one-third as many guitars as banjos. and this one, this orange line down here, is the constraint of you can't make more than 80 of any combination of them. You can kind of see here, it's somewhat hard to see, but this is the area you're really looking at, where all things are shaded over each other. So that's the shaded solution region. And that shaded solution region has corners. It has a corner of 0, 0. That's why I listed it there. That would be don't make any guitars, don't make any banjos, just kind of sit in your hands and don't make anything and don't make any profit. All right? Which may be the best thing to do if there's some way where you're losing money as well. Maybe better just to shut down the company, I suppose. Over here, this corner, remember this is not part of, it is not shaded by everything. This is, you're making more than 50 guitars and you can't. So the corner is not out there, so don't get confused there. So right here though, you're making 50 guitars and you're making no banjos, 50, 0. That's there. You go up, remember this part is not entirely shaded. We have to actually go to this corner here. All right, and I'll get to that coordinate in just a moment. We're going to go to this coordinate there and this coordinate there. Let's go back into Desmos and find out exactly where those are. All right, Desmos is nice and it does a good job. This is, you just kind of press on it, and it's 50, 30. 50 guitars, 30 banjos. This is the alternate, 30 guitars, 50 banjos. All right, and that corner, oh, 30, 50. That one, I'm getting a little confused here, is just make 16 2/3 guitars and 50 banjos. All right. You can't make 16 2/3 guitars, of course. So what we're going to do, because the constraints of this problem is, and I may not be able to do it with my fingers here live, but if you go into Desmos, it may be a little bit easier. You're trying to find the closest integer. Let me grab my mouse. You're trying to find the closest integer to that corner. All right, that is the one corner. It just so happens that, let's see, zoom in a little bit. There's that corner again. It's not an integer. Well, it's not an answer then, if we can't make 16 2/3 guitars, even though that may maximize our profits. So we want to find the closest integer, all right? And it was somewhere in here. Oh, there it just went by, 16 and 48. I don't know if I can get it to stay there. Got it. But because it's not, it doesn't cross any other line there, it kind of disappears. Desmos likes it when they're nice even spots. Like 30, 50. But 16, 48, that was the number in there. So that's another one of the corners. And because it's a real life problem, we have to use the actual integer value. So 1648 was there. 30, 50, 50, 30. And this 2050, that was another integer value I got. So I got 1648 kind of here, and I got 2050 over there. Both of those were the closest integer values to that corner, which was not an integer. All right. So those outskirts of the shaded solution area are potential answers. All right. So you find the coordinates of all those corners, and if you didn't have a calculator or if you didn't have a computer, you'd have to do it out the long way and find the intersection of those equations. But we'll be using technology, hopefully, for most of that. So now we're at the spot where there are three quantities that we're asked to maximize and minimize. And this is just the background. Revenue is the total amount of money taken in, just a definition. Cost is the total amount of money spent, and profit is the revenue minus the cost. All right. In this case, we simplified it, and we're just talking about the $800 and the $300 is the profit. So what we're going to do, this is our last step in this long problem. We're going to plug the coordinates of the corners that we just found into the maximization minimization equation. Into that equation that was way back at the beginning, $800 for a guitar and $300 for a banjo. And the coordinate that gives the largest, or if you're thinking about minimizing costs in a separate problem, the smallest, but the largest in our case, largest profit. And we plug them all in one at a time. and we just figure out which one has the largest value. All right. Now I kind of took a shortcut here. I plugged it in. You don't have to do this. I plugged everything into the old trusty TI calculator. And you can see I used my lists, and I listed all the corner possibilities. And then in, let's see here, in L3, I'm going to set L3 equal to my maximization, $800 for every guitar, plus $300 for every banjo. My guitars are in L1, my guitars are X in a sense, and banjos are in L2, the Ys. And this is going to pump out my profit for each type of thing, all right? And you can see the different profits, but the way to make the most money is to make 50 guitars and 30 banjos. It's right along that line right there, right? 50 guitars, 30 banjos. You make a little bit less making just 50 guitars and no banjos. That was one of the corners. Of course, it doesn't make sense to do it that way. Of course, you don't make any money not making any banjos, and these are quite significantly less, right? So by far, the best way to do it is the 50-30, right? Back into our, here's an example, there's the same thing, so $49,000. So the answer is you will make $49,000 if you make 50 guitars. Whoops, I want to say, let me do this. I won't even make it into an equation. If X equals 50 and Y equals 30. All right. That's one example of linear programming. It is kind of neat. It takes a while. Some of them, the different problems can come at you in different ways, but that's the general way to do it. All right. Thanks for sticking with it, and we'll see you in class.